Remind me, what are the two types of probability? Say them again.
Experimental probability and theoretical probability.
Yes. Experimental probability and theoretical probability. Here we go. So experimental probability, we're going to try this one. If you flip one coin, what are the options of? Okay, you flip a second coin, what are the options? You flip a third coin, what are the options? Okay, every single time you can get heads or tails, right? So there's two possible outcomes for every single one. Nod your heads, dear. Two possible outcomes. So what if we flip 3 coins, but I want you to tell me the outcomes of it. There's ways to be really organized about this. I really like organization. So if you flip 1 coin, what are the 2 options? Okay, so write this with me. So our first option for the first coin, we could get heads or tails. Give yourself some space. We're going to make the tree diagram. Okay, so let's pretend our very first one, we flipped a heads. Okay, well, we're going to flip it 3 times, right? So if we flip that same coin one more time, what are the options? Okay, so that one, next time, could get heads or tails. Well, do you agree if we go over to the pretend tails? What are the options off the tails? We can get heads or tails on that one, right? Okay, but we've only flipped this pretend one twice. We've only flipped this pretend one twice. How many times are we flipping it? So we've got to do another flip. So off of this one, we've got to pretend this, flip this one again, or this one, or this one, or this one. We're going to get lots of outcomes, right? Okay, so off of this one, we could get a heads or tails. Off of this one, we could get a heads or tails. This one, we could get heads or tails. This one, we could get heads or tails. How you doing on your tree diagram? Are you caught up? Okay, question?
Is it going to keep doing that?
It would, but do we need to keep going with our tree diagram? We've pretend flipped it 3 times. These are outcomes. Here's how you can be so organized. On your scratch papers, write down the word outcomes, and let's make a list. Okay, let's just follow our tree and its branches. Let's start here. We could pretend get a heads, and then a heads, and then a heads. Do you see how I just followed the tree down? So that could be our first outcome. A heads, or a heads. Okay, well that's not the only track we could have done, right? Go back to the heads. What if we did heads, then what could it be? We could have done this one next, right? So our next one could have been heads, or tails. That could have been a different outcome. Okay, all right, go back to heads. Change up the color. This branch, do you agree this branch over here is done on the left side? Okay, that one's done, so let's go to the right branch. We could do a heads, a tails, or a heads. So another outcome could be heads, tails, or heads. Okay, are we done with that branch yet? We're almost done though, right? So go back to heads. We could have done a heads, a tails, and then a tails. Heads, tails, tails. Okay, that's just one of them, right? That's if we flipped a heads first, but we could have flipped a what first? Okay, try this tree on your own. See if you can figure out all of those outcomes. I'll leave this up so you can look at it. Double thumbs up. All right, hand in the air. Give me an outcome from the tails tree. Maddie, what'd you get? TTT. You could get a tails, and a tails. Did you come up with a different outcome? Dane, what's a different one? THT. Got it. Thanks, Dane. All right, another one. Courtney, do you have another one? THH. All right, I bet there's one more. Dallin, do you have another one? TTH? How many agree with those ones? Guys, how many total outcomes are there? 8 just for flipping 2 coins. There's 8 total outcomes. Okay, so next to this, put an 8. Box it. There are 8 outcomes. Good job with your tree diagrams. I walked around and they look fantastic. Maybe organized. Okay, so if it asks for the outcomes, here's an organized way to come up with the outcomes and you can list them. What if it just asks you for how many outcomes? Can I show you a trick to these? Get ready, I'm going to erase the board. If you don't have to list, have to say how many, here's what you do. Coins. 3 coins, right? For the first coin, how many options can you possibly get? For the second coin, how many possible options? For the third coin? Okay, we already have a head start. How many outcomes should we get? We already listed them. How many did we get? Okay, we should get 8. There's a way to use that 2 and 8. Don't shout out, let people think for a second. So if you just have to say how many outcomes are there going to be, you just got to think of the options every single time, and then you do something with the options. James, did you figure it out? You do. You multiply them. Guys, what's 2 times 2?
4.
What's 4 times 2?
8.
Yay! So there's a shortcut way if you just have to say how many. Make sure you multiply them. Okay. This one, we're talking about experimental probability today. What are we talking about? Experimental probability. We've already done theoretical like crazy. Today we're talking about experimental. It's all about repeated trials. Keep going. You're playing the game over and over and over again. Okay, back to the coin flip problem. The theoretical probability, I'm going to put the T-prob. The theoretical probability of flipping a heads is what? What do you think, Nicole? It is 50-50. What fraction is that? It's a half, right? And then what's the decimal?
0.5.
Okay, and then what's the
50%.
50%, right? We've got a 50-50 chance. That's theoretical probability. But if I gave you a coin and you flipped it and you flipped it and you flipped it and you flipped it, do you think you'll always get a probability of 50%? No, but let me tell you a story. So I know that you guys will learn about this in the 8th grade, but you should already have a heads up about it. Should already know. So during the Holocaust, there was a guy who was stuck in one of the concentration camps, and he was a mathematician. Now in the concentration camps, it was terrible, right? Absolutely terrible. They had to work really hard. They got very little food, and they weren't allowed to have stuff. However, he had a coin in his pocket, and he's a mathematician, right? So he's just like, what can I do? I have nothing to do. This is the worst possible living situation. What he ended up doing is he flipped that coin over and over and over and over, and he scratched it in the wall. So he flipped it, and he'd scratch for heads, and then he'd flip it, and he'd scratch for tails, and he just kept track. He kept track, and he kept track. So what he was doing was he was doing an experiment, right? An experimental probability. He flipped it, and he flipped it, and he flipped it. He flipped it over 1,000 times and kept track on the wall. When he flipped it 1,000 times, he noticed something. He noticed at first the experimental probability was way off. It was not 50-50. But the more he flipped, the closer it got to 50%. So for example, once he was done, he had like 490 tails compared to 410 heads. So it was really close 50-50. Nod your heads, does that make sense? So if you want to make your experimental really close to theoretical, you just keep going. You keep experimenting, you keep flipping, you keep rolling. The more you do it, the closer they will become. Okay? All right. Will you read it and write down your answer on your paper, please? Okay, hand in the air. Everybody confident. This is how I figured this one out. How did you do this one? Thomas, what did you do? So you did 13 over 20, and then you said you divided them. So you did 13 divided by 20. Okay, what'd you get? All right, so you got 0.65. And then what did you do from there? Move the decimal, boing, boing. So I'm guessing you voted for this one? How many of you got the same thing? Not too bad, right? Okay, how many of you got the same thing, Lexi? Good work, good work. Emails, that's what we can expect. Try this one. Write it down, good luck. Okay, this one. So it says it rains 2 out of the last how many days of March? 12, 2 out of 12. If this trend continues, how many rainy days would you expect in April? Hold it up with your fingers. How many days would you expect in April? Wait, how many fingers? Go over with your fingers. What are you expecting? Then I want to hear from you. Where is this coming from? What are you thinking about this one? Hey, Nicole, what do you think?
So is this 2 out of the 12 days in March? So I just did this, there's more than 12 days in March. So I did 12, 24, 36, and there's not 26 days in March. So I did it twice. It's 12, 24, and then I added the 2 plus 2, which equals 4, because 24 isn't quite the month of March.
Oh, so you round up to 5? Let me see, how many did the same thing? 5-ish days? Alright, well, if it rains 2 out of the last 12 days in March, this trend continues, how many rainy days would you expect in April? I don't know, if we're thinking just about March, and we're just looking at the trend in March, I would say probably just 2 days, right? But if we're meteorologists, is that logical? Is that good reasoning? If we were a weatherman, maybe would we lose our jobs? Yeah, maybe. If we're just saying, well, March, it rained 2 days, so April will probably be the same, right? Okay, so experimental probability, we could say 2 out of 12, but I'm going to stretch you a little bit, and let's keep practicing fraction, decimal percent. So fraction 2 out of 12, guys, reduce that. What is it? Do you have this memorized? Because this keeps coming up over and over and over. What's the decimal? Wait, what is it? Round it, 0.17. So what's the percent? 17%. Okay, next one. Okay, this one is all about rolling a number cube. You know what? I want to do our own experiment with this board real quick. We're going to compare the theoretical probability. So on your scratch paper, put T-prob, and we're going to compare it to experimental probability. Okay, but we're going to have to keep track. We're going to have to keep track of how many 1s are rolled, 2s are rolled, 3s are rolled, 4s are rolled, 5s are rolled, 6s are rolled. We're going to roll a number cube. Okay, we are going to roll a number cube 6 times. How many times? 6. Why 6? Because it'll match our theoretical probability. Theoretical probability, how many times out of the 6 should we roll a 1? Okay, so write that on your paper. Theoretical probability of rolling a 1 should be 1 out of 6. How about a 2? There's only one number 2, right? So 1 out of 6. How about a 3? How about a 4? How about a 5? How about a 6? So everything has one chance, right? We should roll it 1 out of 6 times, but now we're going to experiment. People in the front, you're each going to get a big number cube, and you're going to roll it, and we'll mark it. Okay, Maddie, what did you roll? A 1. I'm going to put it right here. Brandon, what did you roll? A 3. Dayton, what did you roll? A 5. Valeria, what did you roll? A 4. Oh, man, what did you get down? A 6? No way. Kylie, what did you get? 4. All right, our experimental probability. What did we get for the 1s? 1 out of 6. What did we get for the 2s? We got 0 out of 6. What did we get for the 3s? What did we get for the 4s? 2 out of 6. What did we get for the 5s? And what did we get for the 6s? Okay, compare theoretical to experimental. Were we close? Yeah, we were close. Guys, how do you make them almost exactly the same? This is how you'll make any theoretical get really close to experimental. You keep going. We keep rolling, we keep rolling, we keep marking, we keep marking. Eventually those will get closer and closer and closer. All right, put those squishy number cubes top corner of your desk. This one, read it first, try it. Read it first, try it. Okay, let's check your reading skills. This experimental bar graph, how many times was the dice rolled?
50.
Woo, good job reading. 50 times. But the first question says, what is the experimental probability of rolling an odd number? So experimental probability. Okay, odd numbers. Shout them out on the dice. What are the odd numbers?
1, 3, 5.
Good job. 1, 3, and 5. So we've got to take this and adjust it. How many times was a 1 rolled? Okay, how many times was the 3 rolled?
8.
How about the 5? 8. You've got to do something with the 10, the 8, and the 8. Do you know what to do those? Good job. Add them up. What do we get when we add them?
26.
Okay, so out of 50, how many times was an odd number rolled? Okay, so write this down. So this will be our fraction. 26 out of 50. Okay, change that to a decimal. Grab your calculator. Good job. 0.52. Everybody, what percentage is that? Okay, 52%. So we can check off the first question. What is the experimental probability? We've got it. How does this compare with the theoretical probability? Okay, we've got the theoretical. Are you ready on your papers? Okay, so keep track of this one because there's a couple on your assignment that are exactly like this. So now let's do the theoretical probability. Okay, think to yourself, how many options are on a dice?
6.
So stick with that. There's 6 on a dice. How many of those are odd? 3. So what's the fraction For rolling is 1. Okay, there you go. So the fraction for this one is 3 out of 6, or a half. What's the decimal? What's the percent?
50%.
Okay, so this is what we need to do so we can compare. So when it comes to your assignment, make sure you have experiment written out, theoretical written out, and then we can compare. What do you think of those? Look at those two percentages. Are they close? Are they way far off? What do you think?
They're close.
They're pretty close, right? So right here, comparing them, let's just say they're pretty close. You okay with that? Question. Were you listening during the story? Were you listening to the catch-up part? How could you make them even closer? What would we have to keep doing? Tegan, what would we have to keep doing? Keep rolling. Keep rolling, keep rolling. Do more than 50. Do like 100. They'll get closer and closer and closer together. Good work. Thanks, Tegan. Way to listen. Try this one. Pause. It's the same graph, so how many times was it rolled? 50 times. Okay, try it. Okay, what is the theoretical probability of rolling a 3 on a number cube? How many 3s are on a number cube? Out of how many numbers on a number cube? So fraction is 1/6. What's the decimal, guys? Yes, what's the percent? Okay, so that's the theoretical. That is what should happen. However, when you look at the same bar graph, when we rolled it 50 times, how many times was a 3 rolled? 8 out of how many times was 50? Perfect. So 8 out of 50. That's our fraction. Decimal divided. 0.16. Hey, so what percentage is that?
16%.
So when you compare this, what are you going to say? Pretty close, that'd be good with me. So pretty close. Review. How could you make them even closer? Keep rolling. Okay, next. Your assignment.